Hi everybody, Jacob Reed here from ReviewEcon.com. Today we're going to be looking at Unit 2. It's all about supply and demand. We're going to summarize the key points of the entire unit so that you're ready for test day. This video goes along with the Total Review Booklet from ReviewEcon.com. If you're interested in picking that up, check out the links below. Like and subscribe, and if you have any questions, ask them in the comments. Let's get into the content.
This is going to be awesome!
We're going to start off by talking about the law of demand. The law of demand tells us that ceteris paribus, consumers buy more of a good at low prices and less of a good at higher prices. That means that we have a downward sloping demand curve when we graph it out because there's an inverse relationship between the price and the quantity demanded. So when price rises, that causes movement along the curve. Decrease in price causes a movement down that curve and increases quantity demanded. Special thing to note is that price changes quantity demanded. Price does not change demand. It's a key thing that pops up over and over again, and it will trick you if you aren't paying attention. Price changes quantity, not demand. Remember it. There are some things besides price that do shift demand curves. Here are some of our non-price determinants of demand, or demand shifters as they're often called. First, we've got tastes and preferences. When there's an increase in consumer tastes, it will shift our demand curve to the right, increasing that demand. If there's a decrease in tastes and preferences, like something becomes unpopular or it falls out of fashion, that will cause a decrease in demand or a shift to the left. If there are more buyers, also called market size, that will cause an increase in the demand for a product. If there are fewer buyers available, that will cause a decrease in the demand. The next one we have is prices of related goods. When it comes to prices of related goods, there are two types that you need to be aware of. First of all, we've got substitutes. When it comes to substitutes, when the price of one goes up, demand for the other one also goes up. Substitutes mean that one good can replace the other. So when the price of one goes up, people buy less of that good and they buy more of the other one instead. Things like jam and honey. I can use either one on my peanut butter and jelly sandwiches or peanut butter and honey sandwiches. Either one works. So in this example, they would be substitutes for each other. If the price of jelly goes up, the demand for honey is going to go up as well. For complements, that means one goes with the other. When the price of one goes up, demand for the other actually goes down. Here we have the complements, jelly and peanut butter. When the price of jelly goes up, people buy less jelly, but it also causes us to decrease our demand for peanut butter because they go hand in hand. Bread and butter, toothpaste and toothbrushes, ice cream and ice cream cones. All different examples of complementary goods. Next, we have changes in income. For most goods, like shoes, when you have more income, you buy more of that product. So an increase in consumer income will increase the demand, and a decrease in consumer income will decrease the demand. The other type of good is called inferior goods. With inferior goods, when incomes rise, people buy less of those products. So incomes rise and demand actually decreases. Those are things like one-ply toilet paper, or top ramen, or condensed soup. When incomes rise, people buy less of those products. The last one is expectations for the future. Sometimes guesses about what's going to happen later on impact consumer behavior today. That's why when it comes to buying a television, I'm going to wait until Black Friday for when they're on sale. So I demand fewer today, decrease my demand, and then I buy more later. So that expectation for the future changes demand today. If any of those things change, it can cause our demand curve to shift. If we have a shift to the right, that is an increase. A rightward shift is an increase. That means there is a higher quantity demanded at all prices, not just at one particular price. If we have a shift to the left, that is a decrease. A lower quantity demanded at all available prices. A shift to the left. So the next thing we need to do is figure out why it is that demand curves downward slope. The first reason why demand curves downward slope is called the substitution effect. That tells us that an increase in price causes substitutes to look relatively more desirable. And where there's a decrease in price, that makes the alternative substitutes less attractive. So, for example, when the price of ice cream goes up, I buy less ice cream partly because I'm going to buy more popsicles instead. That's the substitution effect. The next reason why is called the income effect. The income effect tells us that there's an increase or decrease in purchasing power as a result of a change in price. Another way of saying this is that when the price goes up, I can't afford as much. When the price goes down, I can afford more. So if the price of candy bars is $1 and I've got $10 in my pocket, then my income of $10 is worth 10 candy bars. But if the price of candy bars doubles to $2, now the purchasing power of my $10 worth of income decreases to 5 candy bars worth. And if the price of candy bars plummets all the way down to 50 cents, that's how much they cost back in my day, then the purchasing power of my $10 worth of income will increase to 20 candy bars worth. And that's the income effect. Another way of saying this is that when prices go up, I can afford less. And when prices go down, I can afford more. That's the income effect in a nutshell. Now let's talk about supply curves. Supply curves are the opposite of demand curves. Before, there was an inverse relationship between price and quantity. With supply, there's a direct relationship. Ceteris paribus, producers produce and sell more at high prices and less at low prices. It's true so often, it's the law of supply. It gives us an upward sloping supply curve. And when prices go up, we see an increase in the quantity supplied, shown as movement up that supply curve. If price goes down, it shows movement down that curve, which gives us a decrease in the quantity supplied. Special note, just like with demand, price changes quantity, or quantity supplied in this case. Price does not change supply. Make sure you know that. It will trick you on your test. But there, of course, are things that do shift supply. We call those non-price determinants of supply. These are your supply shifters. First of all, we've got input prices. Those are the things that go into the production. If the price of a resource that goes into the production goes up, it will decrease supply. If it goes down, it will increase supply. Then we've got government tools, taxes. Per unit taxes decrease supplies. We've got subsidies. Subsidies increase supply. And the last thing is regulations. Regulations will generally, depending on the type of regulation, decrease supply. The third thing we've got is the number of sellers. All right, sometimes people say competition for this one. An increase in the number of businesses that are producing a product will increase the supply. A decrease in the number of businesses producing a product will decrease the supply. The next one we've got is technology. Increases in technology also increase supply. Prices of other goods can sometimes impact supply as well. If the price of wheat goes up, farmers may make more wheat and decrease their supply of corn as a result. The last one is producer expectations. Just like with consumers, the future impacts what businesses do today. If any of those things change, it actually causes a shift in the supply curve. Rightward shift, just like with demand, is going to be an increase. Make sure you understand the left and right instead of up and down, because a downward shift for supply is actually a rightward shift, and that's an increase. On the other side, a leftward shift is going to be a decrease. We're talking about lower quantities supplied at every price. Next thing we're going to look at is the price elasticity of demand. As you already know, when price goes up, consumers buy less, and when price goes down, consumers buy more. Elasticity asks how much less or how much more. That's what we're looking at here. When it comes to determining the price elasticity of demand, there are 6 tests. We're going to look at each of those tests now. The first test is, do you need it? If the answer is yes, odds are this product has inelastic demand, like life-saving medications. If the answer is no, odds are we have elastic demand, like a cookie. The second test is how many substitutes are there. If there are very few substitutes, like for a heart transplant, not much else you can do if you're in the market for a heart transplant, then we're going to have inelastic demand. If we have many substitutes, like soft drinks, then we will have elastic demand. If the price of one soft drink goes up, I just buy one of the others. The third test is how much income does it take to purchase this good. If the item is cheap, the product tends to be inelastic. If it's expensive, on the other hand, like a car versus a pencil, then we have elastic demand. For the fourth test, we're looking at the steepness of that demand curve. If the demand curve is very vertical, at least more vertical than horizontal, then a large change in price will cause a small change in quantity demanded. We call that inelastic demand. If we have a curve that is more horizontal than vertical, then a small change in price will cause a larger change in quantity demanded, and that is an elastic demand curve. The fifth test is the total revenue test. In order to do the total revenue test, you have to do a little bit of math. Price times quantity, that's total revenue. And then you look at what's happening between price and total revenue for a particular range of the demand curve. If price falls and total revenue rises, they're going in opposite directions, that's an elastic demand curve. If price falls and total revenue falls, now they're going in the same direction, both up or both down, that's the inelastic portion of that demand curve. If there's no change in total revenue as there is an increase or decrease in price, we call that a unit elastic demand. We can apply the total revenue test to an actual demand curve. As that demand curve downward slopes, we have changes in total revenue. We call that marginal revenue, and we can graph it with a marginal revenue curve below that demand. You will see that later on in Unit 4 when you learn about monopolies. At the top of the demand curve, as price falls and quantity increases, marginal revenue is positive. That means total revenue is increasing as price falls. That tells us we have an elastic portion of the demand curve up there. Where marginal revenue is 0, that means total revenue is not changing as we continue to produce more and decrease price. That is the unit elastic portion of this demand curve. Further down, where marginal revenue becomes negative, price is falling, quantity is increasing, and total revenue is falling because marginal revenue, which is the change in total revenue, is negative here. That gives us an inelastic portion of this demand curve. In fact, all downward sloping demand curves that are straight or linear will have these three sections: an elastic portion at the top where marginal revenue is positive, a unit elastic point in the middle where marginal revenue is 0, and an inelastic range near the bottom where marginal revenue is negative. Take a look at that marginal revenue curve and it will tell you what the demand curve is above regarding elasticity. On to our sixth test, and this one can be the most complicated at times. It's calculating an elasticity coefficient. In order to calculate a coefficient for elasticity, you need to find the percentage change in quantity and divide that by the percentage change of price. In order to find percentage change, and that can be tricky for some people, the preferred formula for the AP exam is new minus old divided by old times 100. Make sure you follow the direction of the numbers for this type of question. So if the price increases from $100 to $110, that's an increase of 10%. So make sure you calculate that out. There is a better, more exact method that is not the preferred method for the AP exam, and that is called the midpoint method. See the links below to find out how to do that. Once you have calculated the coefficient, you find the absolute value, so drop the negative. In fact, all demand curves will have a negative price elasticity coefficient, which shows us the inverse relationship between price and quantity. If we have an absolute value that is greater than 1, then that demand curve, at least in that section, is relatively elastic. If it is equal to 1, that's proportional changes between quantity and price, then that's the unit elastic portion of the demand curve. If we have an elasticity coefficient that is absolute value less than 1, that means it's the decimal, then we are looking at a relatively inelastic demand curve. Now we have a couple of extremes. Here are the extreme versions. Perfectly elastic is a completely perfectly horizontal demand curve, and that will have an elasticity coefficient of infinity or undefined. If we have a vertical demand curve, that means at any price, one specific quantity will be demanded. That gives us an elasticity coefficient of 0. Those are the perfectly elastic and perfectly inelastic curves. Anything else we call relatively elastic or relatively inelastic. Now we're going to look at some other elasticities. The first elasticity we're going to look at is the price elasticity of supply. The calculation of the coefficient is just like it was for those demand curves. We have the percentage change in quantity divided by the percentage change in price. And just like before, the preferred method for calculating percentage change is new minus old divided by old times 100. You do that for both the quantity and the price, and then calculate your coefficient. Supply curves will always have a positive coefficient because there's a direct relationship between price and quantity. And if the absolute value of that coefficient is greater than 1, it is a relatively elastic supply curve. If it is equal to 1, it's a unit elastic supply curve. And if it is less than 1, it is a relatively inelastic supply curve. Here's what they look like visually. First, we got some extreme ones. We call this perfectly elastic. That's a horizontal supply curve. A vertical supply curve is perfectly inelastic. That'll be a coefficient of 0, where the horizontal one was a coefficient of infinity or undefined. The next one is a relatively elastic one. It's more horizontal than vertical. And then the last one is a relatively inelastic supply curve, which is more vertical than horizontal. This is just the kind of thing we were seeing back with demand, if you recall. Two other types of elasticities we have to know. The first one is income elasticity. Here we're looking at how much a change in income impacts how many people buy at every price. Here we have a percentage change in quantity divided by the percentage change in income. If we have a positive coefficient, that indicates a direct relationship between the quantities people buy and the changes in their income. That's a normal good. If we see a negative coefficient, that indicates a inverse relationship between the quantity people buy and their income. That would be an inferior good. The last type of elasticity you need to know is called cross-price elasticity. Cross-price elasticity is about substitutes and complements. It's about the interaction of the price of one good compared to the demand for another good. Here we calculate the coefficient by taking the percentage change in quantity demanded and dividing it by the percentage change for the other good. Positive coefficients indicate that these are substitutes because when the price of one substitute goes up, demand for the other one also goes up. There's a direct relationship. When it comes to a negative coefficient, that means that there's an inverse relationship between the price of one good and demand for the other good. That means these products are complements because when the price of one goes up, demand for the other one goes down. The next thing we're going to do is talk about market equilibrium. We find market equilibrium when we mix supply and demand on the same graph. Where the two curves intersect gives us our equilibrium price and equilibrium quantity. It's the price where the quantity supplied equals the quantity demanded. The market seeks that equilibrium price and quantity. Sometimes prices are above equilibrium, and that causes quantity supplied to be greater than quantity demanded. That means we have a surplus, and prices will eventually fall back to equilibrium. Sometimes we have a price that's below equilibrium. When that happens, we will have a shortage, where the quantity supplied is less than the quantity demanded. Prices will eventually rise, seeking that equilibrium point. Of course, the equilibrium price and quantity can change when there's a shift in either demand or supply. An increase in demand causes the equilibrium price to increase and the equilibrium quantity to increase. A decrease in demand causes the equilibrium price and equilibrium quantity to both decrease. An increase in the supply will cause the equilibrium price to decrease and the equilibrium quantity to increase. A decrease in the supply will cause the equilibrium price to increase and the equilibrium quantity to decrease. Now, I don't suggest you memorize all these shifts. Just when in doubt, graph it out. Sketch out your little graph and see what happens to equilibrium price and equilibrium quantity on your paper. Most of the time when you get a question, one variable will change and one curve will shift. Occasionally, you could have two variables change. When that occurs, it is possible you could have two curves shifting. Double shifts get a little bit tricky because one of the axes will be indeterminate. Here we have a decrease in supply. That caused the price to go up and the quantity to go down. So we move from one equilibrium point to another equilibrium point. If we add another shift, an increase in demand here, we now have a third equilibrium point. How does this combined double shift impact the price and quantity? Well, both shifts increased the price. That means we know for sure that the price is going to be increased. But on the x-axis there, the first shift decreased the quantity and the second shift increased the quantity. Since these shifts contradict, it really depends on the size of the shifts as to where the final equilibrium quantity is, and as a result, that axis will be indeterminate. Here's another example of a different double shift. We're starting off with an increase in demand this time, which causes the equilibrium point to move, increasing the price and increasing the quantity. If we add another shift, this time it's a increase in supply, we now have a third equilibrium point, and here on that x-axis, the quantity increased on both shifts, whereas the price increased with one shift and decreased with the other shift. Equilibrium quantity will be determined as an increase, but the equilibrium price will be indeterminate. On to a new concept. This is called consumer surplus. Consumer surplus is the difference between the value to the customer and the price the customer pays. One of my favorite lunches is cheeseburgers. My marginal utility for the next cheeseburger is $8, but if I only pay $6, I have a consumer surplus of $2. It's the difference between my marginal utility and the price I pay. On the flip side, we have producer surplus. Producers have the marginal cost of production and the price they charge. The difference between the two is producer surplus. If the marginal cost of that cheeseburger was $4 while the price was $6, the producer will have a producer surplus of $2. Here's what it looks like on the graph. For consumer surplus, you find the equilibrium price in this case, or the price that consumers are paying. You go out until you hit the quantity that consumers are getting, and you go all the way up until you hit that demand curve. In this case, it's a triangle there, and you could calculate the area of the triangle to determine the amount of consumer surplus. On the flip side, we have the producer surplus. You find the price that producers are getting for this product, in this case it is the equilibrium price, and you go to the quantity that they are selling, the equilibrium quantity here, and you drop all the way down to the supply curve. That area there is the producer surplus, and you could also calculate the area of this if there were numbers. Economic surplus is the consumer surplus and the producer surplus added together. A little side note, you could have tax revenue also, and that would be part of the economic surplus as well. When markets without externalities are in equilibrium, we have what's called allocative efficiency. Allocative efficiency means that we are getting the right number of this good or service that is most valued given the marginal cost and the marginal benefit of the product. We reach allocative efficiency when we hit equilibrium for a product that has no externalities. That is where economic surplus is maximized. If we don't reach equilibrium, we will have deadweight loss. Deadweight loss occurs when there is a reduction of economic surplus. Here's an example here. We're selling at P1, that price, it's above equilibrium, and we are only getting Q1 for the quantity. Here, our consumer surplus would be this small triangle. It's the price till we hit the quantity that we're at, all the way up to the demand curve. For the producer surplus, we go to that quantity that we're getting here, all the way down to the supply curve. Those two areas together are our economic surplus. But we have some deadweight loss. The way you find the deadweight loss is you go from the quantity that we are getting in this market and find the marginal cost of that quantity. We find that on the supply curve. The supply curve is the marginal cost curve. We find another point above on the demand curve. That is the marginal benefit of the quantity for this product. The third point we're looking for is the allocatively efficient point. That is where the marginal cost equals the marginal benefit. It's equilibrium on this graph. Those 3 points together give us our deadweight loss. We could calculate the values of all of these shapes if there were numbers here. Now we're going to look at how government intervention in the market system can impact consumer surplus, producer surplus, and deadweight loss. First, let's take a look at a price floor. A price floor is a government intervention that establishes a minimum price for a product. It makes it illegal to charge less. Minimum wage is an example of a price floor. If a price floor is going to be effective or binding, it must be above equilibrium. That's right, the floor is up high. Here's what it looks like on the graph. There's our supply and demand curve without any government intervention, and the government puts a price floor above equilibrium. At that higher price, there is a lower quantity demanded, higher quantity supplied. But the difference between those two is our surplus. Not economic surplus, not consumer surplus, not producer surplus. It's a surplus. That means the quantity supplied is greater than the quantity demanded at that higher price. The quantity demanded, which is the lower of the two, is the amount that is actually sold here. So that is the quantity we get in this market with the price floor. At that higher price, we have just a small triangle of consumer surplus. We have a pretty large section of producer surplus. The producers here might like this price floor, but we have deadweight loss here. And that's because we do not reach the efficient outcome of reaching equilibrium. Another government control we could get is a price ceiling. Price ceilings are maximum prices for a product. If a price ceiling is going to be effective or binding, it will be below equilibrium. By the way, if they aren't below equilibrium when they're a price ceiling, or they aren't above equilibrium when they're a price floor, that means they are ineffective, and we just go to equilibrium. So here's what a price ceiling looks like on the graph. The price ceiling goes below equilibrium because it's going to be binding in this example. And at that artificially low price, the quantity supplied is less than the quantity demanded. That causes a shortage, where the quantity demanded is greater than the quantity supplied. That's what we call it, a shortage. Now, at that artificially low price, the quantity supplied, the lower of the two, is all we're going to get in this market because we don't get to buy more than is going to be produced. There is our producer surplus. It is a small triangle there based on where that price ceiling is all the way down to that supply curve. And then we have a big area there of consumer surplus. But since we aren't reaching equilibrium at the quantity we've got, we have a triangle there of deadweight loss. We could calculate the area of all these shapes if numbers were given. Now we're going to look at the impact of per unit excise taxes on a market. There's our equilibrium again. We've got our equilibrium price and quantity. If the government imposes a per unit tax on this good, it will shift the supply curve the vertical distance of that tax. And we will have a new equilibrium, which has a lower quantity with the tax. Also, at that new intersection there, we get the price that buyers will pay. That is the price you see at the store when there is a tax on this particular good. If you follow that new equilibrium down to the old supply curve and then out to the price axis, that gives you the price that the sellers receive after paying the government the tax. We could shade in that box there. That is the amount of the tax. It's the vertical distance between the two supply curves, the supply and the supply plus the tax, times the distance or the base there, which is the quantity we sell at with the tax. So that gives us our tax revenue box. We could calculate that and find out how much money the government is bringing in as a result of putting a tax on this item. We have just a small area of producer surplus. Since PS is all that producers get, you go till you hit that original supply curve, drop down, and that gives us the producer surplus we have as a result of this tax. The consumer surplus is up there. It's where the price the buyers pay until we hit the quantity we're at, and then up above until you hit that demand curve. And then we have a triangle of deadweight loss. Right? Remember, a little side note, little helpful reminder is that the triangle of deadweight loss points to the allocatively efficient quantity, which here is the equilibrium quantity. You can calculate the area of all those shapes if there were numbers for sure. The next thing we're going to do is take a look at tax incidence or tax burden. What we're looking at here is who pays the tax when the government imposes a per unit tax on a particular good. There's a myth out there that all of the cost of a tax will be passed on to consumers. But it really depends on the elasticities of the supply and demand curves. The way you figure it out is the less elastic curve will pay more of the tax. Here we have the demand curve is less elastic than the supply curve. And as a result, the consumers have a bigger portion of the tax incidence. How do you figure it out? You divide the tax revenue box from the old equilibrium. The top portion is the buyer's loss and the bottom portion is the seller's loss. That tells you who is paying a bigger portion of this tax. If we have the supply curve that is the less elastic of the two, then the sellers will have a bigger tax incidence than the buyers. Here are the extremes. Here we have a perfectly elastic curve, none of the tax. When the supply curve is perfectly elastic, all of the tax will fall on buyers. If one of the curves is perfectly inelastic, like this demand curve here, then all of the tax will go on that curve. In this case, the burden is falling entirely on consumers. If we have a perfectly inelastic supply curve, then the entire burden falls on sellers. The last topic for this unit is trade and tariffs. We're going to take the ideas we've already learned, supply and demand, and apply them to international trade and tariffs. Let's take a look at the supply and demand curve for international trade. We have an upward sloping domestic supply and a downward sloping domestic demand. And then we're going to add in a world supply curve at a lower world price than would be for the domestic equilibrium price and equilibrium quantity. At that low price, we have Q1 is the quantity that producers will actually produce or make at this low price. Q2 is how much consumers will want to buy at that price, and the difference is imported. Q2 is how much consumers get, Q1 is all that's produced, so that gap, the gap between there, Q2 minus Q1, is the amount that will be imported from the international markets. To find the producer surplus at that world price, you go from that world price until you hit the supply curve, because Q1 is all that producers are getting to produce, domestic producers that is, and that gives us a triangle of domestic producer surplus. For consumer surplus, it's not just till you hit that equilibrium. We go all the way till we hit Q2. So this whole area here is our domestic consumer surplus with international trade. Now this scenario is pretty good for consumers. But if you are a manufacturer of this product, you'll notice that the producer surplus is pretty small. So these producers may lobby Congress and the president to install some tariffs on this good. If we put tariffs on this good, that will cause the world price to shift upward. We now have the world price plus the tariff, which gives us the world supply plus the tariff. At that new higher price, we have a lower quantity that's imported. Price goes up for the domestic producers, so they produce Q3. They produce more now. But less gets imported, and consumers don't get to consume as much. They will consume Q4, so Q4 minus Q3 here, that is the amount that will now be imported. So there's a lower amount that's imported as a result of the tariff. Producer surplus grows a bit. Consumer surplus shrinks a bit. But there is another benefit, and that is some tariff revenue. The amount that is imported times the height of that tariff, the gap between PW and PW plus the tariff, that is our tariff or tax revenue as a result of the import tax. But here's a downside, and this is efficiency loss. We have two little triangles of deadweight loss as a result of the efficiency lost from the tariff. That's surplus we could have had, but we lose out on as a result of the tariff. And of course, you could calculate the values of all of these if there were numbers on the graph. Whew, we made it through it. Now that's everything you need to know for that unit. If you already knew all of that stuff, you are on your way to doing really well on your next exam. If you still need some help, head down to the links below and head over to reviewecon.com, where there are lots of games and activities to help you practice and relearn those skills that you need to know. If you want to support this channel, please like and subscribe below, and then head over to reviewecon.com and purchase the Total Review Booklet with all of the